Okay, so welcome everyone to STEM Lab's Competition Mathematics tutorial series. And in this, our first topic, we will be talking about algebraic manipulation. And okay, this is probably one of the most basic skills you will need in any mathematics competitions, the ability to work with equations and algebraic expressions. Okay, so here we will be starting with one particular technique under algebraic manipulation. You will need to know how to use special products. So let's look at some of our common special products, starting with the square of binomial, which is given by a plus or minus b squared, which gives you the trinomial a squared, plus or minus 2ab plus b squared, and the sign of the middle term depends on the sign between the two terms in the binomial. We also have the difference of squares, which is the result of multiplying a plus b times a minus b, which gives us a squared minus b squared. That's the difference of squares. We also have sum of cubes, which is given by a plus b times a squared minus ab plus b squared, and the product here is given by a cubed plus b cubed. And we also have the difference variation of that, the difference of cubes, which is given by a minus b times a squared plus ab plus b squared equal to a cubed minus b cubed. And remember, we can easily identify if it's sum of cubes or different of cubes by the sign in the binomial. If it's plus here, it is also plus in the product. And if it's minus here, it's also minus in the product. Also keep in mind the middle term in the trinomial factor is the opposite sign of the operation in the binomial factor. Here are the problems that we will be talking about here in this video. And I think this would be a nice time for us to pause. Let's pause the video here first, and why don't you give these questions a try? And when you've tried them and you're ready, uh, continue the video to see the solutions. Okay, if you're ready, let's begin. Let's look at question number 1. Question number 1, we are given the sum of two numbers is 4 and the sum of their squares is 7. What is their product? So if we're going to write this given algebraically, so suppose our numbers are x and y. So the given is telling us x plus y is equal to 4. It's also telling us the sum of the squares is 7, which means x squared plus y squared is equal to 7. And the question is asking for what is the product. We're looking for xy. So anytime you see questions like this, what you really want to think about is how can we relate these given expressions to each other? And again, if you recall the special products we just talked about, then there is a particular one among those products where we see a relationship between x plus y, x squared plus y squared, and xy. Remember which one that was? It was this one. Square of binomial. x plus y squared is equal to x squared plus 2xy plus y squared. And here we can plug in some of the values we know. We just found out x plus y is 4. So we can change that. This is 4 squared. On the other side, we are told x squared plus y squared equals 7. So the x squared and the y squared combine to give you 7. And that still leaves us with plus 2xy. So at this point, it's just a matter of simplifying the equation. 4 squared is 16. 16 equals 7 plus 2xy. 16 minus 7 equals 2xy. 9 equals 2xy. And finally, this gives us xy equals 9 over 2. That is what we were looking for. All right, let us now look at the second question. Second question is, the sum of two numbers is 5 and their product is 3. What is the sum of their 6 powers and their 9 powers? So once again, let us suppose that our numbers are x and y. So working with the given, we are told that x plus y is equal to 5, the sum. We are also told that x times y is equal to 3. And we are looking for x raised to 6 plus y raised to 6, the sum of 6 powers. Okay, so this one's a little bit trickier than the first one. Let's see. Okay, first, let's examine the expression x raised to 6 plus y raised to 6. Okay, so we can use some special products here, right? Notice that the 6 powers are in fact both cubes. We can write this as x squared cubed plus y squared cubed. And let's very quickly recall what we said earlier. The sum of two cubes, a cubed plus b cubed, is given by a plus b times a squared minus ab plus b squared. Okay, so following this pattern for x raised to 6 plus y raised to 6, we have x raised to 6 plus y raised to 6 equals x squared plus y squared times x raised to 4 minus x squared y squared plus y raised to 4. Okay, so there's still some stuff we don't know here, but I think we're getting closer. First of all, let us focus on x squared plus y squared. Now remember, we already know that x plus y is equal to 5. We also know that x times y is equal to 3. So using the relationship we already used in the previous question, x plus y squared is equal to x squared plus 2xy plus y squared. Now let's try filling in the values we know. We know that x plus y is equal to 5, so we have 5 squared. we also know that x times y is equal to 3. So notice we have x squared plus 2 times 3 plus y squared. Okay, so now we have 25 equals x squared plus 6 plus y squared, which means, just flipping it around, x squared plus y squared is equal to 25 minus 6, which is equal to 19. So now we have one value. We know that x squared plus y squared equals 19. Okay, but now what do we do about the other factor of x raised to 6 plus y raised to 6? Now we're looking for x raised to 4 minus x squared y squared plus y raised to 4. Now, we just found out x squared plus y squared equals 19. Now notice that this expression in red here, the value we're looking for, the expression we're looking for, looks a lot like the square of a binomial. Note, x squared squared is x raised to 4 and y squared squared is y raised to 4. So let us try using that. So if we square this expression using the same pattern of the square of a binomial, we get x raised to 4 plus 2x squared y squared plus y raised to 4 equals, on the right side, it's 19 squared, which is 361. Now this expression that we now have is not quite the expression we're looking for. Recall that we also know x times y is equal to 3. The middle term is in terms of x squared, y squared, so let's square this. So if we square that, x times y equals 3, we get x squared, y squared is equal to 9. And now we can get to the expression we are looking for, right? So there's a couple of ways to do it. Let me do it this way so it's very clear. We replace the x squared, y squared. We have x to the 4th plus 2 times 9 plus y raised to 4 equals 361. And we have x raised to 4 plus 18 plus y raised to 4 equals 361. And if we subtract 18 from both sides, we can see x raised to 4 plus y raised to 4 is equal to 343. But we're not done because I want an minus x squared y squared in the middle. So we're just gonna subtract that expression. X to the 4th minus x squared y squared plus y to the 4th is equal to 343. Again, that expression minus x squared y squared is equal to 9. So when we subtract minus x squared y squared on the left side, we just subtract 9 also on the right side, so that this expression is equal to 334. Alright, and we are now almost done. Remember, we already found out x squared plus y squared equals 19. X raised to 4 minus x squared y squared plus y raised to 4 is equal to 334. So putting those two things together, remember we were looking for x raised to 6 plus y raised to 6, and we determined that that is equal to x squared plus y squared times x raised to 4 minus x squared y squared plus y raised to 4. So plugging in the values that we now know, x squared plus y squared is 19, and the trinomial factor is 334. 19 times 334 is 6,346. That is the value that we are looking for. 6,346.